Welcome to the AI Chat Podcast. I'm your host, Jaden Schaefer. Today on the podcast, we have the pleasure of being joined by Chris Lattner. Chris is an incredible entrepreneur and currently is the CEO of Modular, a company that has raised over $100 million recently. They just did a round of funding. They're building some really incredible things in the AI space. So we're super excited to dive into all of that with Chris, talk about his journey and everything that they are doing over there. So thanks so much for coming on the show today, Chris.
Yeah, well, thanks for having me. It's great to talk to you.
Would you mind telling everyone a little bit about Modular and what it is that Modular does, like the problem that it's currently solving for customers?
Yeah. Well, so Modular is a relatively new company. We're less than 2 years old at this point. We really decided to tackle the AI infrastructure problem in a very different way than most other people are. We decided to go all the way down to the hardware software boundary and tackle that low level, how the hardware is driven, how the layers of software, which make up these modern machine learning frameworks and the infrastructure and the serving components, all these things got put together and rethink them. And so we started from that layer because there's so many things in the space, right? It seems like every quarter a new blog post comes out and they say, here are the top 57 things you need to know to do AI correctly, right?
Yeah.
And and I don't know about you, but it's a little bit unsustainable, right? We can't
Sure. Yeah.
build and deploy systems where you need 57 different technologies all wired together. And so
100%.
our philosophy is that you need fewer things that work better. And what we're trying to do is drive out a lot of the complexity from the system. What that means is that we need to go and rethink things. We need to redesign things from first principles. And so Modular is taking a hard tech approach to this. We're building compilers and runtimes and heterogeneous things. We're working with the insides of TensorFlow and PyTorch. We're trying to do this in a very user-centric and customer-centric way because nobody wants to rewrite their code,
Yeah.
right? And so what we're doing is we're building out that fundamental technology layer that we think can drive a lot more usability, a lot more programmability, accessibility, and things like this into this AI ecosystem.
And
Now, if you want, we can talk about all the components of that, but that's a high level intro.
yeah. I want to dive into that. But first, I want to take a little step back. So right now, you're the CEO running Modular. This is an incredible company solving a lot of problems. I would love to talk a little bit about your journey. What brought you to this
Mm-hmm.
point? What got you into software? What got you into AI to
Mm-hmm.
begin with?
Mm-hmm. Yeah, so I grew up as a in the 80s mostly as a nerd. So I
Okay.
fell in love with computers very early on, first playing video games on like the Commodore 64 and things like this. Switched over to learning how to code in a serious way and kind of worked my way up through things. Eventually got a series of degrees in computer science and then entered the workforce. Most of my DNA comes from Apple. And so I spent
Okay.
11 years at Apple building developer tools of all sorts. This includes low-level compiler technologies like this LLVM framework, but also programming language Swift, which I created, and then also was leading the entire developer tools ecosystem with Xcode and the entire developer platform. Around the end of 2016, I fell in love with AI.
Okay.
And so since that point, I've been on this hero's journey of trying to understand AI from all the different parts of this. So I started in applied AI at Tesla. I worked on Google TPUs, scaling them, getting them to work, and really getting that novel accelerator and needing new kinds of software to plug into TensorFlow and PyTorch and trying to understand that part of the problem. Switched to the hardware side of things, and so led a hardware team where we were building AI hardware itself and then building the software that goes with it. And through this journey, kind of have been looking at all the different pieces of this. And through that, what it really reinforced is it's a mess. Like whether you're on the hardware side trying to build a novel chip and you're trying to get people to use it because you need people to use your stuff, or whether you're a software developer and you're looking to deploy something, this whole world is just so complicated. And so
Right.
this is kind of what led to Modular. And my co-founder and I, Tim Davis is my co-founder. We got to know each other back at Google, working on a bunch of cool projects together. And what we realized is we need to kind of take a step back. And a lot of the people in the space are, they're highly invested in technologies that were built 5 to 6 to 7 to 8 years ago, and they're all hill climbing those things, right?
Yeah.
But if you look at modern neural networks and modern AI, it's very different than it was back in 2015. So.
Yeah, and so that's incredible. Talk to me a little bit. I just wanted to double click a little bit. You said
Yeah, please.
you created Swift. What was your role in Swift, working with Swift and at Apple?
Yeah.
Obviously, very incredibly popular. The programming language that is used to create all iOS apps and everything in their app store.
Yeah.
So talk about that.
Yeah, so I joined Apple in 2005, and one of the projects I was able to work on there is this LLVM framework that I started as part of my graduate research, and I was able to bring LLVM to Apple, productize it, and then went on kind of this journey of replacing GCC with an Apple. And so by the time we got to 2010, that's when we had launched Clang, which is a C and C++ compiler. And so that was a full stack replacement for GCC for all of C, C++, and Objective-C, which is the technologies that Apple uses. Now, coming out of that, C++ is, how should I say it? It's a wonderful and very rich language, has many powerful features. Implementing it is a very fun and interesting technical challenge. And
An
having launched
optimistic
that,
spin on it.
yeah, I'm being nice. It's perhaps not beautiful, but it's very pragmatic, right? There's a lot of great and many layers of technology built into C++. Coming out of that, I was kind of in the mode of saying like, okay, well, prove that we could do this, but really, is C++ the thing? And so at the time, I was managing a large team of quite a few people, and so it's just a nights and weekends hobby project started, and said, okay, well, let's build something next, right? And let's see if we can get the iOS and the Apple ecosystem to move from Objective C onto something new. And so I spent probably a year and a half just in my spare time hacking on this thing and building what became Swift. Got it to the point where a year and a half in, it was interesting. I kind of understood it. I'm the kind of person that needs to build something to really understand the
Yeah.
thing. And then I approached management at Apple and said, hey, I've been working on this thing. What do y'all think about it? And they're like, oh, well, that's interesting. Sounds complicated. But I had a good reputation. And so they're like, okay, yeah, you can have one or two other people work on this. And so the project slowly grew within Apple. By the time we got to 2014, we launched it publicly. And so we said, hey, app developers out there, you can build Swift applications and submit them to the store. And so that whole journey was epic. Went on for multiple years later to open source it later and do a bunch of other things. Continue to be involved in the Swift project even after I left Apple. And so, yeah, Swift is a really, really great project. And I think it's really been widely adopted within the Apple ecosystem. And Apple's using it for everything from writing kernel extensions to writing applications for UI and things like this, which is really, really quite wonderful.
This is incredible. And I'm sure you have many like lessons and takeaways that you get from this experience. But for me, it's so cool to see someone that this was your hobby project within the company, right? This wasn't your job.
Yeah.
They didn't say, hey, Chris, come in, build Swift with like 100 other people. Like this is obviously a very important piece of software. So you would imagine that like it could have a huge team. This is your hobby project. You're an entrepreneur, right? You're starting your own thing inside, and then it ends up scaling and being this huge thing that's a major part of the company.
And for what it's worth, that's not unusual for me, right? So LLVM itself started that way. So LLVM is this compiler technology that underlies Clang and Swift and Rust and Julia and like all TensorFlow and PyTorch and like all the stuff that needs high performance. That started again as a hobby project. So I'm working with my advisor back at University of Illinois. He was having me work on some stuff, and I was like, okay, well, how about I like create something more interesting to nerd snipe him into allowing me to work on this thing. And so LLVM started from that. Years later at Apple, right, started working on getting LLVM to be production, had a big team built around it and a lot of really good people working on this, and said, okay, well, everybody knows it's impossible to write a C and C++ parser, right? What does impossible mean? Like, is it impossible or is it just really hard? And so again, worked on what became Clang for, I don't remember, it feels like a year or so, something like that. Just kind of understand it and kind of, again, got to the point where it could hit some interesting metrics. It could prove the use case. It was a long ways away from being completed, but then again, brought it to Apple management and said, hey, wow, would this be cool? And it was super funny. I remember my manager at the time was like, wow, that's super weird. Like, I didn't think that you cared about languages. I thought that you just were a code generation person. I'm like, well, I like working on really interesting technical problems and learning cool things. And so, you know, I've kind of have this habit of wanting to build things to understand them and then work through that and bring it to production. And all phases of that journey are super exciting and interesting to me.
That's amazing. Yeah. And obviously like that's how you can build crazy and impressive things that you're passionate about. So that's incredible. One question I will ask you is, you know, starting from this sort of like you're creating these languages, you're working in this space. What kind of what brought you into AI? What you're currently doing today? Like, was it that you were like intrinsically interested in AI, or
Hmm.
is it just kind of like the natural progression of where like your industry was going? Like what brought you
Yep.
into that space?
Well, so I really fell in love with AI back in 2016, right? And to me, it started from just very much this is a new kind of science time.
Okay.
2016 was a long time before ChatGPT, right? And so this was where, it was a combination of what people were doing back in 2016. It was just recognizing dogs and cats and images and things like this, right? And the thing to me that was fascinating is that there's no good way to do that with traditional software. Like you can't write a series of for loops and if statements to find out if something's a cat versus a dog. It
Right.
doesn't really work, right? But deep learning was like a new form of programming. And so as a person who cares about developers and of like being able to build cool and innovative software, it's like, oh, well, there's a thing here, right? And so from that point, then got involved in the system side of it. And so the compilers and the big accelerators and stuff like that. And what I realized is that, okay, well, not only is it an algorithms question, it's also hardware. It's also new kinds of compilers. It's this new generation of technology. And what a modern machine learning framework and system does is it produces a higher level of abstraction, like the graph, for example,
Mm,
right? And one of the things that's really, again, I fell in love with is that it's a fundamentally different kind of programming, and it has fundamentally different kinds of powers than what traditional programming languages enable. And so, I remind people, like, again, 2016, that's when people were talking about, let's go democratize AI,
yeah, yeah.
right? And you fast forward to now, and we have people that are working in Jupyter notebooks writing Python code, and they're spinning up clusters with exaflops of compute,
Right.
right? So something happened there, right? And part of my
Right.
journey through Google is helping build a lot of that technology, and there's something fundamental there. And so one of the challenges with today's systems, though, is that a lot of the today's systems end up being these point solutions that are really optimized for one specific use case, one specific piece of hardware,
Mm,
one specific research group, one specific kind of model, whatever it is. And so a lot of what Modular is doing is saying, okay, let's learn from that. Let's take all the learnings that the industry has done. Let's take all the research. Let's take all the many cool point solutions and systems have been built. And let's build a world-class implementation of that technology in a really easy to use, actually good system. And so, again, what we're doing is we're saying, okay, well, we don't need to do research here. We have, Modular is a company based on 6 or 7 years worth of research from both Tim and
mhm.
I and many of the people in our team. We've been building all these systems. And so getting the chance to do it again and do it right is really quite powerful.
That's amazing. Um, incredible company. Talk to me a little bit about so your the founding of Modular, how this thing got started, what
Mhm.
that looked like, what was the like paint me a picture here, right? You're working in these
Yeah.
corporate jobs, you're at Tesla, you're at Google, you're at Apple, and you're
Yeah.
doing these kind of things in your career. Like what was the moment when you were like, oh my gosh, like I need to start my own company, I need to co-found this
Yep.
with
Yep.
Tim? Like what was the conversation? Did you like, hey Tim,
Yep.
like I have this idea, or Tim call you up? Like what
Yep.
did this
Yep.
look like?
Yeah. Yeah. So time frame's a little bit more complicated than that, actually. So
Okay.
I left Google in January of 2020. That
Okay.
was right before the pandemic struck,
Okay.
and there's a whole story there. But I left Google because I really wanted to be working on this ML infrastructure,
Okay.
and at the time, I kind of had this feeling that PyTorch was winning and TensorFlow wasn't, and it wasn't the right place to be. But I also wanted to go work in a startup.
Mhm.
And so the smallest company I'd worked at that point was Tesla, which is not exactly a tiny little company, right? And so I joined a hardware startup. And so that was super interesting because, again, I got to work on the hardware software boundary, but this time seeing how the chips were made. And
Cool.
so learned a tremendous amount and worked through that. The pandemic struck, that led to lots of interesting excitement at the company, built up new kinds of technologies, learned how all this stuff was built, and then
Mhm.
understood at a much deeper level how accelerators had to fundamentally work, and
Mm.
therefore what the software had to look like. It's like, because understanding both the physics that the hardware people are dealing with when putting transistors down, but then understanding the abstractions you can build on top of it together was something that was really eye-opening to me and really helped complete my worldview.
Mhm.
At the same time, Tim had stayed at Google, and so he rose into the ranks and was on the product side and was product managing all the mobile stuff, the data center stuff, like all this infrastructure for
Mhm.
AI there. And we kind of, for both of our parts of the journey, kind of got into this point of where we realized nobody's really working on doing the fundamentals, right? People have built all these systems and they're hill climbing them. So
Right.
the PyTorch team is going to make it more PyTorch. The TensorFlow team
Right.
is going to make it more TensorFlow. The NVIDIA team's going to invest in their stack. The Apple people are going to
Yep.
invest in their stack, whatever, right? And there's nobody that's looking to unify this tech,
Mm-hmm.
right? Of course, Meta's not going to work on TensorFlow, right? Everybody knows that, right?
Yeah. Yeah.
What would you expect, right? And so we got this idea to say, okay, well, let's actually set up a company that can be independent. And being independent is actually really important because AI is so big, it's so important to so many different people that roughly everybody's competing with each other,
Yeah. Yeah.
right? All the cloud companies want to kill each other. All the hardware people don't get along. All the LLM companies don't get along, right?
Yeah.
There's the Tesla and the PyTorch people. They're like dogs and cats, and they're
Yeah.
both delightful, but they don't get along super well, right? And so what we decided to do is say, okay, well, let's be an independent company and let's be focused on making the world's best thing. And what that means is, let's be real. Some people use PyTorch. Some people use TensorFlow, right? Particularly if you're talking to enterprises, they've been building and deploying AI into their systems for 5+ years in many cases. And so they have a little bit of this, a little bit of that. Nobody really knows how it all works anymore because the people that built it maybe have moved on. And so there's this big, big mess. And so what we decided to do is say, cool, let's clean up this mess. Let's build this unifying technology that can work with both TensorFlow and PyTorch. And that's production quality, it's commercially supported, has really phenomenal performance. I mean, we can often improve performance by like 2 to 3 times, for example.
Wow, impressive.
That then enables people to have bigger models, which is also a really big deal. And as you kind of lean into this, you start to realize, well, this stuff is so important that the fact that the complexity is fractal and it's just exploded means that actually it doesn't fit in anybody's head. And so there's this huge gap between what theoretically can be done if you have a team of 100 people that are the experts in everything versus what people are actually doing. And what we're trying in practice, and what we're trying to do is we're trying to close that gap between theory and reality. So.
Okay. Very impressive. And so, just bringing it back to the beginning of Modular for a second. So you guys have this vision, you see you need to like connect these technologies, PyTorch and Tensor and all this stuff. So what was like the conversation that you had initially with your co-founder? I mean, you guys had worked together, but like, was it like, hey, like, let's do this thing. Let's put this together. Like he was working at Google, I'm assuming. So he had to quit and come in. Like, how did that work?
We both had full-time jobs. I mean, so he and I knew each other. We had become friends. But as you say, it's never that simple, right? You have to be, your timing has to be right. You're both giving up the opportunity costs of doing something else, right? And so we both could take a different big company job and be the lead of whatever of AI at some other really established important company. And so we had to make sure that we aligned on what kind of company we wanted to build, how we wanted to approach that. One of the things that was really important to both of us is to start with the business model.
Yeah.
In 2021, that was kind of a novel concept, but it turns out it's
a little bit more popular today.
It seems like a good thing. I'm a little bit old school. I kind of go back to the, try to build core value and solve problems for people. And particularly if you alleviate suffering, people are often willing to pay for that. So, yeah. So we worked through all of that and then decided to incorporate the company. And so we started in January of 2022.
That's incredible. And I mean, you guys have obviously seen a lot of success from the very beginning. Again, like I mentioned at the beginning of the podcast, a big congratulations on raising $100 million. You've just raised recently for Modular. Can you tell us a little bit about how this is going to accelerate Modular's mission to, fix AI infrastructure for the world? What this is going towards?
Yeah, totally. You've covered us before, so I'll repeat your own words. We're using it to build a team. So one of the things that's really, I think, underappreciated is that the technology that we're building is really, really hard and requires a lot of really specialized experience. And it's actually perhaps more difficult to hire a compiler engineer than an engineer who knows how to train a machine learning model, right? Just because in terms of talent, people have been training neural nets and learning how all the AI application layer works for many years, and many computer science graduates come out of school knowing this. But the technology stack, the hardware software boundary, is really niche. And so what we're doing is we're competing with effectively the big companies to try to hire the world's best talent and build a really unique team. And so we've been doing that quite successfully. We have some of the people that have built TensorFlow and PyTorch and Onyx Runtime and TVM and like XLA and all of these systems that people have been using. And so we're pulling together these folks and giving them the opportunity to build something that's really fundamental and profound. where before many of them and us were all kind of stuck hill climbing,
Mm-hmm.
right, and stuck in the constraints of the host organization. Now we can actually build the right thing for the world. And so the primary spend is on people. It turns out people are very expensive these days. And one of the things that's very unusual is we're not just spending on, AI compute hardware or something like that.
Mm-hmm. Okay. Very interesting. Yeah, and I think this is an incredible use case. Building out that team today is such a incredible, value add for the company. Something I'm really
Yeah.
interested in talking about that a lot of people have asked about in relation to your company is Mojo, right? So you,
Yep.
as we talked about at the beginning of this, which is kind of why I was interested. You've had a really fundamental role in developing Swift. Over at
Yep.
Apple. So Mojo's kind of touted, for those that don't know, as like a new programming language for all AI developers that combines the usability of Python with the performance of C. So what was
Mhm.
the kind of idea? What was the directive behind creating Mojo? How does it differentiate from existing languages like Python or Julia?
Yeah, yeah, great question. So let me tell you where it came from first, and then
Okay.
we'll tell you what it accidentally means to the world.
Okay.
So when we started in modular, like we were talking about, we wanted to solve some very fundamental hardware software boundary kinds of problems,
Mhm.
right? And so how do you make a GPU go burr? How do
Right.
you have a massive cluster of machines talking to each other? How do you build this layered software architecture that is usable by Python and by millions of machine learning engineers worldwide, right?
Mhm.
And so the state of the art had been to write everything in CUDA, write everything in C++, write everything in Python, and have this unholy mix of all these systems that don't really talk to each other very well, but kind of with enough duct tape and baling wire, you can make this thing work. And so, as we're tackling this, there's a bunch of other really fundamental technologies like kernel fusion, and there's a whole bunch of tech that you need to be able to program these heterogeneous machines, because
Mhm.
it's not all about a GPU. Turns out that GPUs don't do data loading from spinning disks. You need a CPU for that,
Right.
right? And so as you're actually building out an AI technology stack, you get exposed to all this complexity.
Mhm.
And so what we did was we said, okay, let's go and build a really novel compiler.
Mhm.
And we started without any syntax at all. And
Okay.
so we just handwrite the internal representation that the compiler used and proved that we could generate state of the art performance, that we could express the things we needed to do. And we built out this core technology. And we got to the point where we said, okay, it's seeming to work, but now nobody can use it because there's no syntax for it. And so what we did was we went shopping and said, what syntax do we think we should use for this? And so, you could either do like Swift did, which is you invent a new programming language. We could use C++. We could use an existing thing off the shelf.
Mhm.
But we realized that none of them would work very well. And so what we decided to do is, for a person and for a team who's built programming languages before, you say, okay, well, why don't we just do something new? But instead of inventing new syntax, why don't we just follow Python?
Okay.
And the reason for that is that everybody in AI already knows Python.
Right.
And like most people love it, except for performance and certain limitations and challenges, right? Most people love it. And so if we can take the part they love and then we can solve the problems with it, we think we can have something really, really nice. And so what Mojo is it's a completely new compiler runtime stack. It's super efficient, designed. It's not designed to be an improvement to Python. It's designed to work backwards from what the physics allows us to do with the hardware.
Okay.
But then it's a member of the Python family. And as it builds out, it becomes a full superset. And so what you can think of it is it becomes to a programmer like Python++,
Uh-huh.
where
Okay.
you can take forward everything you know about Python and you don't have to retrain, like everything you know will still work. But then if you want to add types to it, if you want to adopt new features, then you can get better performance, you can deploy with fewer dependencies, you can get a lot of the benefits that Mojo provides you.
Ah, okay. Yeah, I see a lot of really incredible benefits in that and what you guys are building. I think it's probably would be a very it probably seemed like a very daunting task for most companies and people to create something like that. Of course, with your experience, you
Yeah.
and like also just kind of hearing your background and some projects you've worked on, you seem like the kind of guy that if there's something daunting, you just, go ahead and do it
Yeah.
anyways and jump right in. So,
Well, yeah, I mean, I think there's an aspect of that, but it's also let's not kid ourselves. Building a new programming language and doing it the right way is a huge amount of work,
yeah, seriously.
right? This is a huge amount of work, and it's like we were talking about before, extremely expensive to do
Yeah.
this, right? And so we're not taking the short path to have a quick hack to make a demo.
Uh-huh.
We're taking a much more difficult path knowing that it's difficult, so fully informed, have been there, done that,
Hmm.
uh, but believing that the outcome will be worth it, right? And so
Yeah,
that's one of the things that I believe in. Where, you know, I believe in AI. I'm an AI maximalist. I think it can reinvent so many experiences we have, and that there's so much technology here. And so
totally.
what I'd like to do is I would like to make it much more accessible to people, so that people can not just train the model, but they can actually deploy it,
Yeah.
right? So they can invent new algorithms that fully utilize the hardware. Like these things, I just believe will lead to progress. And
Hmm.
so the fact that you have to do really hard stuff, I mean, to your point, isn't daunting, because I like to do that kind of stuff. But to me, that's just okay. Well, is it worth it or not? Like,
Yeah.
is the investment in time and energy and things like this going to lead to something fundamental? And I believe the answer is yes.
Yeah, that's incredible. I think having that conviction obviously is been a huge asset to you. This is why you've gotten so many incredible things done. I think modular has been such a success. One thing I'm interested about with modular, I'm wondering if you can elaborate a little bit on how the modular compute platform dynamically
Yeah,
partitions and distributes models with billions of parameters. What kind of
yeah,
efficiencies and scale can developers expect?
yeah. Yeah, so my background, as we were talking about, goes back through decades of working on compilers, right?
Hmm.
And so I don't consider myself to be just a compiler person, air quotes, but I
Hmm.
know I know when and where compiler technology can be particularly valuable, and how to use it the right way. Use it for great justice, not for not for full employment of compiler engineers, right?
Okay.
The And so when I saw the rise of these AI systems, so you take TensorFlow for example,
Hmm.
the core abstraction in TensorFlow is a graph, and a lot of the way that TensorFlow was built initially was by kind of distributed systems people. And so a lot of the initial architecture of TensorFlow was to scale this graph across a cluster.
Hmm.
And if you have a graph, you can have each node turn into message sends and things like this. And so when a compiler person, or a person with background in compilers like me, comes into this, I start to realize, okay, well, this is actually a much more fundamental concept than just something that, just a machine learning thing. And so bringing that technology, the compiler technology, the distributed compute, the low level runtime, the code generation, like all these pieces to bear, that allows you to really understand what the graph is doing in a way that people haven't been able to do in the same way before. And
Hmm.
so there's a whole bunch of this technology that then allows you to, for example, partition a model across multiple machines, or do it in parallel horizontally across thousands of chips, right?
Mm.
And so it really comes down to using a graph and understanding that compute declaratively,
Hmm.
instead of looking at for loops and semicolons and things like this. And that's one of the reasons that Mojo and the AI engine that we're building is an epoch of technology different than something like Swift or Rust or C++. It's just like a different category of tech. Of course, in the simple case, when you're running on one CPU or something like that, it's the same. But allowing you to scale out to this much more complicated, heterogeneous computer is pretty cool, and I
Hmm.
think quite fundamental.
Super cool. Yeah, and it does sound very fundamental. I'm wondering, based off of you're building some really incredible tech. You're attaching, you're allowing people to work
Mhm.
with TensorFlow, PyTorch, all these different things. I'm wondering if you could share some, real world case studies or success stories from people currently using your tech and seeing some of the
Yeah,
benefits from it.
yeah. So I mean, it's really hard to give you one answer, because we have thousands of people
Yeah, yeah.
and hundreds of thousands of developers. I mean, just today, somebody kind of so. As we're recording this 3 days ago, we just launched Mojo as an SDK, so you can actually
Okay.
download Mojo and use it locally on your Linux box.
Oh, very cool.
Um, Already people are like rewriting llama models in Mojo, and
Really?
they're like doing incredible things. But the thing that's really cool about AI is it spans everything. So we're
Mm,
working with internet companies doing recommender models for movie prediction, like maybe you should watch this movie next. We're working with people that are doing like fluid dynamics and things that
mm,
aren't really AI, but are using AI tech. Working with people that are in the generative space, and so I mean, AI goes everywhere. Cars have a ton of autonomous systems in them,
yeah.
and so this is one of the fun things about AI is it's not a cat detector, right? It's
Mhm,
it's a fundamental new kind of technology that gets used in pretty much any place that you want to interact with humans or with the natural world, right? And
mhm.
I look at it as AI is the best way to deal with the modality of real life.
Yeah, yeah. Very cool. So something that I would be very curious to hear a little bit more about. I know that Modular's cloud compute platform is set to launch in 2024. I'm wondering if you can give us a little bit of, if you
Yeah,
could talk a little bit about some exciting things we can expect from that. Training at scale and managed and BYOC, all that kind of stuff. What are some things that people can
yeah.
expect with this launch?
Yeah, so what we've done is we've approached the market with the goal of meeting customers where they are.
Hmm.
Okay, and so a lot of people are using a lot of technology that's, as we were talking about, super fragmented and very
Yeah.
complicated, but they've built a lot of existing systems around them,
Hmm.
right? And so our approach in our today products are really designed to meet people where they are, even if it's unfortunate.
Okay.
Okay, and so our first product is the AI engine. It works. It's kind of like a Docker container, right? And
Okay.
so the cool thing about this is you can run this on your cloud, any of the clouds. You can run this on prem. You can run this on a laptop. You can run it any system you want. You can orchestrate it. You can ML ops it. You can do whatever it is that you're doing. If you have crazy security stuff, it fits and it just works. Now, the challenge with that is that you have to build all that complicated, crazy stuff, and people are asking us for more, right? They want to
Right.
defragment all of that stuff built on top. I mean, so many enterprises say that they want a unified AI platform for all their teams. And so
Hmm.
what we're doing is we're starting at the bottom, build systems that drop and replace and embrace people where they are, but then give them new things. And so our hosted platform becomes much more like a SaaS product where we'll host the compute for you,
Okay.
um, and therefore take a lot of the burden of scale, maintenance, reliability, deployability, all this kind of stuff off your plate, so you can focus on building your applications on top of AI instead of having to babysit it and decide which ML ops platform of the day is the right one for you.
Right, right. Yeah, and I'm sure that that saves people a ton of time, and really, the more headaches, like you kind of mentioned, the more pain you take away from people, the
Yeah,
the happier they are, the more they love your platform. That's really exciting. Very,
yeah,
very cool, and excited for the launch of that next year. So, as we kind of wrap up this interview, I would be really curious to ask you. You and your team have worked on a lot of really incredible technology, PyTorch and all sorts of different things that are really integral to AI today. And I'm wondering if you have a piece of advice for developers, for companies that are currently implementing AI into their organizations from a high level perspective. What's a piece of
yeah.
advice or you could give to those people?
Yeah, I mean, to me, the thing about AI is it's so exciting because it is. I mean, even you go back a year ago, people were kind of skeptical. They had heard about these things. Some people were thinking about, do they need an AI strategy? But
Hmm.
now it's very clear that AI is here to transform a lot of product experiences, a lot of the expectations that people have, and so it feels sometimes like it's difficult to keep on top of things, right?
Hmm.
And I guess one of the things I would just encourage is, unless you're a researcher inventing new algorithms,
Yeah.
just assume that new research is going to come out. Right?
Okay.
Assume there will be new models. Assume there's going to be new innovation. Assume there's going to be new hardware. And so look to a way so you don't get stuck on one thing, right?
Okay.
And so you need a little bit of insulation so that you can benefit from the new research. You can benefit from, like, this world is changing so quickly, right? It really is important to not get stuck, right? And
Yeah.
so that's one of the things where it's hard, but this is where we're trying to help level up the world and make it so that people can actually work with all the technology, even if it's changing, because
Hmm.
the research innovations are just amazing. Like,
Totally. Totally. I love that advice, and I think that's so crucial, and I guess that's really the massive value of modular, right? Because all these companies would be stuck with all this tech debt, or like essentially, it's hard
yeah,
for them to move with the times and come with everything new that is coming down the pipe if they're not able to integrate with it with their old tech. And
yeah,
so modular kind of helps bridge that gap and does some impressive things. Thank you
yeah,
so much, Chris, for coming on the show today for sharing your insights and your story. Really incredible, really inspiring for a lot of people. Love what you're building. If people are interested in trying out modular or some of your platforms and tools,
yeah.
what's the best way for them to find that and kind of look at some of the things you're building?
Yeah, you can go to modular.com and there's get started button. You can download it and start using it today. So it's super
Incredible.
easy.
Awesome. And I'll leave a link to that in the show notes.
Yeah.
To the listeners, thank you so much for tuning in to the AI Chat podcast. Make sure to rate us wherever you listen to your podcasts and have a wonderful rest of your day.